Well, hey everybody, Mr. E's back with you for our third and final video on lesson 18.4. So in the first video I introduced the lesson. In the second video I worked through a bunch of practice problems, but I got a little long in that second video, so I decided to make this third video where I can do some application problems. All right, so just a few problems here at the end. All right, so I am on page 582 if you are interested in the Accelerated Math 7 textbook. All right, so Lisa says that the indicated angles cannot have the same measure. Marita disagrees and says they can. Well, let's go ahead and set these two equal to each other and see what happens. So 9x minus 25 plus x, we want to know, can that equal x plus 50 plus 2x minus 12. And of course we want to simplify these down. So 9x plus x, that gives me 10x minus 25 is equal to x plus 2x, that's going to give me 3x, and 50 minus 12 is going to give me 50 minus 12 is going to be 38, right? Okay, so I know this equation is going to have a solution because if you take a look at the terms on each side, the variable terms, this one is 10x and this one is 3x. They are not the same, which means we're going to have a solution. But let's see what happens when we actually solve it. Well, 10x minus 3x, that's going to give me 7x minus 25 is equal to 38. If I add 25 to both sides, I get 7x is equal to, let's see what we got here, 8 plus 5 is 13. We got 63. I love that. It goes in evenly, and I get x is equal to 9. So we have a solution. Let's plug that solution in and see what happens. All right, so this one here, again, I'm actually going to go to my simplified ones here. All right, so this one on the left-hand side is going to be 10 times 9 minus 25. So that's 90 minus 25. And 90 take away 20 would be 70. So this one would be 65 degrees. And then on the other side, 3 times 9 plus 38. Well, 3 times 9 is 27. And 27 plus 38 is going to be 65. So 65, that would be 130 degrees. And since the total of the angles of a triangle is 180 degrees, this would be 50. So I do not see any reason why these two angles could not be equal with a measure of 65 degrees each that you get when x is equal to 9. So I'm going to have to say, I'm going to go with Marita is correct. I just do want to warn you that sometimes you can have a solution for the equation, but when you put it in the application, it doesn't work. So for example, I was wondering if maybe we were going to get a negative measure for an angle, or if maybe they would add up to a number that was greater than 180, because that would not be possible as well. All right, Adele opens up an account with $100 and deposits $35 a month. Kent opens up an account with $50 and also deposits $35 a month. Will they have the same amount in their account at any time? All right, so if we look at Adele, we've got 100 plus 35m. If we let m be the number of months, okay, number of months. So for Adele, we have 100 plus 35, and over here we're going to have Kent, and Kent has $50, and he is adding $35 a month. All right, will they ever be the same? Well, since they are adding the same amount each month, that means that they would have the same amount when 100 equals 50. Think about it. Adele started with 100, right? Kent started with 50. Will he ever catch up? No, he'll never catch up. He's always going to be $50 behind, right? He's always going to be $50 behind. So, will they ever have the same amount? No. Never. They will never have the same amount of money. All right. Okay, a couple more, and then we're going to be done. Frank solved an equation and got the result x equals x. Sarah solved the same equation and got the result 12 equals 12. Frank says that one of them is incorrect because you cannot get different results for the same equation. Well, let me ask you this. If I write x plus 12 equals x plus 12, all right, what would happen if I subtracted 12 from each side? What do I get? I get x is equal to x. Kind of looks like what Frank got, huh? If I write that same equation, x plus 12 equals x plus 12, but instead this time I subtract x from each side. Whoops, let's be consistent and use red here. If I subtract x from each side, what do I get? I get 12 is equal to 12. Kind of looks like what Sarah got. All right, it's the same equation, and this equation has infinitely many solutions, right? Infinitely many solutions because the left-hand side always equals the right-hand side. All right, so both of them have the correct solution, but so that means that Frank is wrong. All right, so it's actually the same solution solved differently. All right, they didn't get a different solution. They just got the same solution solved differently. Anytime the left-hand side equals the right-hand side, it will have infinitely many solutions. Same solution solved differently. Sorry, Frank. All right, and the last one, Matt said that 2x minus 7 equals 2 times the quantity of x minus 7 has infinitely many solutions. All right, well, Matt, so sorry. All right, this is one we throw at students a lot because they look the same, but when you apply the distributive property, what do we get? We get 2x minus 49, right? And right now you should see that these two are the same, right? And if I subtract those away because they are the same, I get negative 7 equals negative 49, which means, of course, there is no solution, right? This has no solution. No solution at all. All right, and we knew that because these two x terms will always be the same, but negative 7 will never equal, ever equal negative 49. All right. And that, boys and girls, ladies and gentlemen, is the end of lesson 18.4. Hope you had as much fun as I did. Till next time.